In this video we're going to consider a second aspect of asymmetric information, and that is moral hazard. So with moral hazard, it's a case that a principal cannot observe the actions of the agent. And we're going to analyze moral hazard in the context of optimal taxation. So the thing that we're going to be looking at is an agent I who can choose to earn a certain income, denoted by X, and that income is going to be subject to taxation. So the government at the margin is going to use taxation equal to tau. So when you earn an income X, you're left with a net income equal to 1 minus tau times X. And the government is going to use this taxation income that it earns on the marginal tax rate tau to provide everybody with a basic income tau 0. And finally, there is an effort cost for the agent of earning a certain income. Yeah, so agent I has an effort cost Ci times the income that is earned, and the more income you earn, the higher the cost and the marginal cost of work will be. Yeah, so this is the utility function that we're going to be working with. And the assumption here is that C, or Ci, is private information. And actually, the government only observes Xi. So the government can use Xi for taxation, so Xi can be used to tax. Yeah, but the government cannot observe Ci, so it cannot make taxation conditional on the cost level of the agent. So we're going to generate an economy where we have a vector of cost levels, and this time I'm going to use PyMC3 to generate this vector instead of TensorFlow. So we're going to draw agents from a log normal distribution with a mu equal to 0 and a standard deviation equal to 0.5. We can have random draws, and the size will be 50, so we're going to draw 50 agents in this economy. And then I'm going to define the effort level for an agent who faces a marginal tax rate equal to tau and who has an individual effort cost equal to C. So what does this agent do? He solves the following problem. So it's going to be SciPy, optimize, and we're going to use the function minimize here. So we're going to minimize minus utility. So there's going to be a minus here. And utility is going to be equal to X times 1 minus tau minus C times X squared. So I'm leaving out tau 0 here because it does not affect the optimization problem. So it simplifies notation a bit. And then from this optimization problem, I return the value of X that actually optimizes this objective function. So it minimizes minus utility. So just to see what this gives us, so this is one part of the trade-off that the government faces. So I'm going to define a range of tau, which is going to be numpy range between 0 and 1 in steps of 0.1, and then we're going to plot the range of tau and the effort that is going to be invested for each level of tau for an agent who has Ci equal to 1. So we do this for tau in range tau. And as you can see, this relationship between marginal taxation on the horizontal axis and income earned or effort invested by the agent is a negative relationship. Yeah, so the higher tau is, the lower your net income is, and the substitution effect then suggests that indeed you work less. Yeah, with this simple utility function we don't have an income effect, so it's just a substitution effect. The higher the taxation, the marginal taxation used by the government, the less people will work. So to get the trade-off in this optimal taxation problem, we're going to introduce a welfare function which actually gives the government an incentive to redistribute utility between its citizens. And the instrument that it can use to do that here is taxation. So the welfare function the government uses is that it sums over all its citizens. Oops, this is LaTeX, so it's going to be to the power rho, and then here we do it to the power 1 over rho. So this is the welfare function that is used by the government. So it takes the utility level of each individual, it sums it, takes the utility level to the power rho, and then the overall thing will be to the power 1 over rho. So to understand why this actually gives us an incentive to redistribute, we're going to plot this function in a simple example. So let's define this welfare function for the government. So U is going to be a vector of utility levels for all the individuals in the economy. I'm going to fix rho at minus 1.5. So in the notebook that you have to do for the course, you're going to be looking at different values of rho to see what happens to the optimal tax rate. And then we're going to implement the utility function that you see here. So we're going to sum. And it's going to be v to the power rho for v in the vector u. And then this whole thing will be to the power 1 over rho. So we're going to define a range of u here equal to, it's going to be equal to 0, then we're going to go to 0.51. I'll explain in a second why we use this range. And then plt plot range of u, and then welfare is going to be equal. So this economy is going to have 3 individuals. So the first individual gets 1 minus 2 times u. The second individual gets u, and the third individual gets u as well for u in range of u. So let's plot this and I'll explain what's happening. So we have 3 individuals here. The first individual, when u is 0, gets everything, so he gets 1. And the second one and the third one get 0. If on the other hand u is equal to a half, which is the maximum in this interval, the first guy gets nothing, and these two are pretty rich because each of them owns half the economy. Now if you look at welfare, the distribution where the first person gets everything and the other ones get nothing actually yields very low welfare. And similarly, in this point, where there is again one individual who has nothing and the other two are quite rich, utility is very low. And utility here in this economy is maximized when u is equal to 1/3. Yeah, so when each individual in this economy has exactly the same utility level. So when this is your welfare function with rho smaller than 1, and we're looking at the negative rho, so that's certainly smaller than 1, the optimal thing to do for the government is to set utility in such a way that everybody in this economy has exactly the same utility level. Now the problem for the government is this desire for redistribution has to be traded off against the fact that if I increase the tax rate, total production, total income in the economy decreases. So to see how these two things add up, we're going to plot welfare as a function of the marginal tax rate. So I'm going to define welfare as a function of the marginal tax rate. Now the first element here is that for each marginal tax rate I calculate what the basic income is that everybody will get from the government. So the assumption here is that the government has no other expenditures. It uses everything it earns from the marginal tax rate tau to have a basic income for everybody tau 0. So how much does it get? So it earns tau, a fraction tau of the income from everybody. That income itself is a function of tau and c, for c in gamma. And then this function returns welfare, the function that we just defined. So for welfare I need to give it a vector of utility levels. So that vector is going to be 1 minus tau times the effort that people choose, and that effort is a function of tau and c, plus everybody gets a basic income, so everybody gets a tau 0, and of course minus the cost of effort, which is a function of tau and c. So we need to square that effort term for c in gamma. And now we can plot this. So we have a range of tau, and we have w as a function of tau for tau in range tau. So here we can see the trade-off that the government faces. So if you increase your marginal tax rate, first welfare will go up. So although production is going down, welfare still increases because we're redistributing between the rich and the poor agents in the economy. But if we continue to redistribute, so if we continue to increase the marginal tax rate, the loss in production outweighs the desire for the government to redistribute. So there's an optimal tax rate, which in this economy is about 0.2. And that balances exactly the desire for the government to maximize the total pie in the economy and its desire to redistribute that money equally between its citizens.